to AP Computer Science, Assignment 12. Exercise 5.4 has us write a method, public static int, greatest common divisor between two integers for math op. It returns the greatest common positive divider of two int parameters. If either is negative, multiply by -1, then repeatedly place the larger by the remainder from dividing the larger by the smaller until one evenly goes into the other, in which case 1 will be the greatest common divisor. And what do you do if either is 0? Well, in that case, it's unsolvable because you can't divide by 0. Well, how do you factor out the greatest common factor from a couple numbers? In the beginning, you were taught to first divide both numbers by 2, then 3, then 5, then 7, and basically all the numbers that can't be divided by any other. Well, it would be almost impossible to do that with coding. I mean, how high do you want to go, right? 51, 53. You keep going on and on dividing these. Well, there's a simpler method. There's what we call Euclid's algorithm. So how do you solve using Euclid's algorithm? You get the greatest common divider with two numbers. Say in this case we use 20 and 75. 20 goes into 75 3 times. It has a remainder of 15. So then we take this 15, that's the remainder or the modulo, and divide it into the divisor, the smaller number. So that goes 1 time, and it comes up with the remainder of 5. Then we take the remainder here, the modulo, and divide it again into the divisor, and it's even. It comes out to be 0. So the greatest common divisor is 5. Okay, so I know you can do this in your head. You can look at 20 and 75. So yeah, the greatest common denominator is 5. You don't have to do anything to figure that one out. But you might take you a little more time with a larger number. Let's take, for instance, the greatest common denominator between 1,173 and 357. You go take 357 into 1,173 3 times, and you come up with the denominator of 102. So the 102 goes into the divisor 3 times. The modulo goes into the divisor 3 times, and its remainder is 51. So the modulo goes into the divisor 2 times. In this case, it's even. So then the greatest common divisor is 51. See what I mean? You save yourself a lot of time by doing Euclid's algorithm. So how do you make this into a formula? Well, very simply, you got to realize when you make a division, what are you doing? You're saying the dividend, this dividend here, is equal to divisor, this is divisor, times the exponent, which is 3, plus the remainder, or the modulo, which is 102. So that's exactly what it would look like. This would be breaking it down. So you can see, you can code something like this. So here, of course, the divisor now becomes a dividend, and the remainder now becomes a divisor. Okay, so if you take the dividend is equal to the divisor times the exponent, you come up with the new modulo. So then you take your new dividend, which is your old divisor, and you take your new divisor, you multiply it by the exponent, and eventually you should come up to 0 as you go through this process over and over again. So now we're going to turn this operation into Java code. So we're assuming that the smaller number here is A, okay? And I'll show you a little bit how you can turn that A into the smaller number if it's not the case, okay? So we're going to call something a temp, and we're going to load the B value into it, okay? The B is what? The bigger number. So B is equal to A modulo B. So whatever the remainder is when you divide A by B is now going into the B value. So now A becomes what? Whatever the A temp is. In this first case, in the first go around, it's going to be whatever the value of B is. But it's going to change as B changes. Okay? And you're going to do this over and over again until B becomes 0. So then we're going to turn this into real code. So we're going to say loop until B equals 0. So as long as B is not equal to 0, then we've got our code in here. The same code as we have here. And then, of course, the value we return is A. So if you're given two numbers and you're going to find out what the greatest common divisor is, you need to make sure that the first number is smaller. Suppose you are given two numbers and the biggest is first. How do you deal with that? You got to turn them around, right? Well, how do you turn them around? A little trick in programming. Okay? So here's an example. Greatest common divisor between 7 and 6. A is equal to 7, B is equal to 6. 7 is bigger than 6. What do? You put the sum of A and B into B. So now B becomes the sum of that. So 7 and 6 here is 13. So B is now 13. So now you say A, 7, is equal to B minus A. So now what does A become? 13 minus 7 becomes 6. So now A is a smaller number. See? You put 6 over here now. So how do you turn B into 7? What you do is you take B, which you've loaded up 13 into B, which is the sum of A and B, is equal to 13 minus A, minus 6, right? So now, there you see, little tricky thing there. Now you've turned the two numbers around. I hope that helps you. So how do you code that? Well, here you have it. If B is greater than A, then what you do is you load up B with A plus B. You have A is equal to loaded B minus A. Then you put B becomes loaded B minus A. And that'll bring you this. Before we put all this together, next thing we have to do is determine if either A plus B is less than 0. Okay. If either of them are less than 0, you multiply whichever one is by minus 1. So this is how you code that. So if A is less than 0, you take A and multiply A by minus 1. And if B is less than 0, you take B and multiply that times minus 1. Okay? So let's go code this. So what we do is we copy our Chapter 5 listings into Chapter 5. We don't have the network yet defined, so we're not going to be able to work with this yet. But we're going to go and work with these. Okay, I'm going to open up the map op. So what we do is we declare our greatest common divisor and declare our two integers. So the first thing we do is we make sure that neither A or B are negative. So if they are, we'll multiply it by -1. And the next thing we do is we make sure that A is higher than B. If A is not higher than B, we switch them around. How do we do that? So if B is higher than A, what we do is we give B the value of A plus B. And then we make A the value of the sum minus A, which would effectively give us B. And then we take B, which is the sum, is equal to B minus A. That's how we switch them around. So then we go find the greatest common factor. Once again, using Euclid's algorithm. Okay, so as long as B is not equal to 0, we have a temporary value assigned to B, and we take the modulo of A divided by B, and then we have A becomes now a temp, okay, whatever the remainder is from the previous formula. So then all you have to do is once this bumps out and B becomes 0, you return this value A. That's the problem. Exercise 5.5. Under what circumstances can a call of a class method be polymorphic? So the question was, under what circumstances can a call of a class method be polymorphic? So here we are in Chapter 4, page 22. Here's our definition of polymorphism. And what does it tell us? Polymorphism is the execution of polymorphic method calls. So what is that? A command is said to be polymorphic if it has more than one form. They give us, for an example, with the definition of fill slots has different effects depending on the class of the object executing the command. So what does that mean? That means that method's polymorphic if it has two different signatures. In this case, say this method produces an int and this method produces a string. They can be said to be polymorphic. A call to a class method may be polymorphic if there is another class with the same name that has a different signature. Exercise 5.6. Write a math awk class that finds the factorial of a given int value. For example, 6 factorized is 6 times 5 times 4 times 3 times 2 times 1. Watch out for negatives. I think that the exercise 4.6 is designed to give you an introduction to recursion. So what you're doing is the factorial of 6 is 6 times 5 times 4 times 3 times 2 times 1. So actually, it's pretty straightforward in a little sense if you can wrap your head around it. First, you have to say, if the number is less than 0, the factorial of it is going to be 1, okay, minus 1. If the factorial is 0, it's going to return 1. So then we also add to this, if num equals 1, return 1. So these are the cases that, a factorial might not produce the results you expect. So what you do is you would put in here an else statement. If it isn't one of these situations, then return the number times the factorial of the number one below it. So it goes back, say, like 45, 44, 43, 42, 41. It goes backwards until it gets to 1, and then it goes back forward. So that's how you would do it. So then you would compile your class, and let's run it. Okay, so I'm in math operations, and I can do my factorial here. I know 6 factorized is 720. Let me see if that works. Yep, 720. Let's try the other one while we're here, math op. And here we go, greatest common divisor. So we'll put 256 and 8 to return 8 as our greatest common denominator. Sure did. Okay. So you need to check them out before you turn them in. Make sure you did it right, not just compiling. Exercise 5.9. Change the person class of listing 5.2 so that any outside class can find out the smallest birth year of all the persons who have been created so far. Use -1 for the answer if no persons have been yet created. Exercise 5.10. Change the person class of listing 5.2 so that any outside class can find out the average birth year of all the persons who have been created so far. Use 0 for the answer if no persons have yet been created. This is a listing, and it will be in your class, okay? So we're just going to modify this to provide us with the lowest birth year. So I'm back in the chapter, back in the exercise. I right-click, open up the editor for my person class. So the first thing I want to do is I want to add a variable, the smallest birth year, and I want to instantiate it to -1. Next, I want to have a variable for the average birth year, and I want to instantiate it to 0. As you can see, right at the beginning, I have just added these two things. Before you can use a method, you need to declare them. So the next thing I'm going to do is I'm going to actually go into the birth year, the constructor, and I'm going to add this to the constructor. So the first thing I'm going to do is I'm going to assume that somebody is the first person entered here. So if the number of persons is equal to 0, then the smallest birth year is going to be 0. Otherwise, it'll be the year of this person, the first person we're entering. So I'm going to write that in. Right after super, click enter, and I'm going to write it. Okay, now I need to make an else statement. Otherwise, what? If the smallest birth year is less than the year that this person has, then the smallest year is going to be this person's year. So I'll put my else statement in. Here we go. So now I've got it written. I've got to call it somewhere. So I'm going to come in after, tell how many different persons exist. I'll put that right after that. There we go. I'm going to return smallest birth year. I'm going to write my method. Public static, and I want to return an int, get smallest birth year. Okay, now what I'm going to do is I'm going to just have my method return the smallest birth year. So there you go. And then I'm going to return the average birth year. And it'll be like the smaller birth year. It'll be public static get average birth year. Then I'll put the code to do that in here. Return the average birth year. Okay, that's all there is to it. You return the smallest birth year, and because you already put the coding up here. Okay, let's compile it. No problems here. So all you did is you made those little changes to the person class, and you're done with that. That was a fast exercise. Exercise 512. Rewrite listing 4.6 to store both 1 and 100 in named public final variables standing for the lower and upper limits, then use them wherever appropriate. So for exercise 512, all I'm doing here is I'm rewriting this listing to store both 100 and both 1 and 100 in named public final variables standing for the lower and upper limits, then use them wherever appropriate. So, and I would add some variables to this, 2 of them in fact. I would add public static final int limit low equals 1. Then I would add public static final int limit high equals 100. So then I would modify this over here in user's first choice. In its secret number, I would replace 1 with limit low, and I would replace in parentheses here 100. I'll put limit high minus limit low plus 1. So that's what we're doing. We're just changing this guest number class. So there are 2 files that I need to borrow from the Chapter 4 assignments. One file is the guest number class, and the other file is the basic game class, because the basic game class depends on the Java file. So I'm going to click this, and I come down, hold down the control key, and I'm going to click guest number Java. I need both of them. I'm going to right click copy, and I'm going to go into my Chapter 5 assignments, and I'm going to paste them both so that they're right inside my Chapter 5 assignments. Now I can bring them up in my BlueJ. So here's my BlueJ. I can click Edit. I can click Add Class from File. So I bring up Basic Game and click Add. And then Edit, Add Class from File. Then Guest Number. Okay, so now I'm going to right-click Basic Game, and I'm going to compile it. Right-click Guest Number, and I'm going to compile that. So now what I'm going to do is I'm going to go into the Guest Number file and make those couple changes here. So I click into Editor. I come in here, and I'm going to be adding a couple of integers. I'm going to be adding a couple of variables. So I come down. I'm going to add a limit low variable. I'm going to add a limit high in this. Now you'll notice that both these variables are public. Public because you're going to allow other classes to use them. Now what we're doing is we're going to replace its secret number here with its secret number equals 1 with limit low. And I'm going to replace 100 with limit high minus limit low plus 1. Plus 1. Now, what did you notice? You notice that my number's in all capital letters. Well, why is that? Because these are static variables, correct? You got it. So that's all you have for this exercise. Neat, right? One thing. So it's going to compile it. Okay, and we got to make sure that you have enough in space around the negative, or it's going to throw you an error. Okay, that's it. That's that exercise 513. 513. Rewrite the NIM constructor for enlisting 4.8 to use the local final variables for the numbers 21 and 3. Then use them wherever it is appropriate. So you're going to do a very similar thing in 513. So just like we did in Guess the Number for the NIM, what we're going to do is we're going to add a public static final integer called starting range is equal to 21. And then we're going to add a integer's public static final removal range equals 3. What we're going to do is replace 21 here and ask users first choice with starting range. And we're going to replace this 3 with removal range. That's all we're doing. We got to put this listing into our exercises, don't we? So we'll just copy it. And we'll right click paste it, or copy it. So now we're in the Blue Jay chapter 5. So all we do is we go new class. This class name is NIM. Okay. Now we go inside the NIM class. Delete everything they've got in there. Paste it in. So what are we doing? We're going to be adding a couple of our own variables here. We're going to be adding starting range. Okay, we're going to set the starting range to 21. It's a public, see, it's static once again, so it's all capital letters. Okay, we're going to add the removal range equal to 3. So then we come down to public void ask users first choice right here, and we're going to replace that 21. Replace that with starting range. Replace this with removal range. And then we'll compile it. That's 513. Listing 515. An attempt to move on or back up or to evaluate CCD when it is illegal calls an abrupt system exit without an explanation. The user would appreciate a tracing output in such cases. Revise these 3 methods to call a public method that explains the problem with show message dialog and then terminates. So what we're going to do with exercise 515 is we're going to go into the Vic class. We'll right click, go open editor. So the only thing I have to do with these is to put up a message. Here in this case, I added the message before I had the system exit. J option pane, show message dialog, none, could not back up. In order to do that, I had to add this at the top, right? Import javex.swing.joptionPane. So now what do I do with this one? Public void move on. This is the second method. I put the J option pane, show message dialog, null. In this case, you cannot move on. So I'm just going to stick this here. Copy this. And I'll put it right before the system exit. So in this case, what can't we do? What's the error code here? Error code's going to be could not what? Move on. No slot exists, right? So the last one we're doing this to CCD. It's going to be cannot CCD. There's no slot. So I'm going to click enter. Paste that in. Could not see CD. There is no slot. So there you go. So all to do is compile it. And we're finished.